All right, I'm continuing with this subnetting skills challenge. We're going to subnet this network. We're going to create addresses for all of these subnetworks, and then we're going to take it all into Packet Tracer, and we're going to configure the whole network with static and default routes to make it work. So in the last video, we did the R1 router, and we created the address space for the R1 router, and we did the R2 router and the address space for the R2 router. In other words, we took this address space 172.20.0.0/16 and we subnetted it for 4 subnets of 1,000 hosts each. And we did this one. We took this address space and we subnetted that for 4 networks of 60 hosts each. So now we have to do this one over here. We're going to take the 172.24.0.0 network address space /16, and we're going to subnet it for 4 subnets, 4 separate networks of 5,000 hosts each. So this is how we'll do it. We've got open up Notepad here. I've got my binary place values for 8 bits here. At the top, this is 2 to the 0 place, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7th. All right, and this 2 to the 7th power is 128. Okay, and let's see here. All right, and now what we need to do is we need to do this network here, 172.24.0.0/16. I have it here, 172.24.0.0/16, and we're going to, we need 5,000 hosts for each subnet. Well, our host, we can tell how many hosts we have in our subnet by how many zeros are there. So you can see here that if we have 8 zeros, right, 2 to the 8th power is 256 or 256 hosts. That would be a normal Class C subnet mask of 255.255.255.0. And we'd have 256 hosts, 254 of which are usable. Can't use 0, can't use 255. And then if we add another 0 here, we get 512 hosts, and we add another 0, we'd get 1,024 hosts, and so on and so forth. And we get down here, we can see that if we have 5 zeros here and then 8 zeros here, right, that's 2 to the 13th power, we would have 8,192 hosts. And that's what we're going to use to create 4 subnets of 5,000 hosts each. So our subnet mask would be 255.255, and this would be 224. All right, 224.0. Now, how did I get that? Well, this is the 128-bit right here. This is the 64-bit, and this is the 32-bit. And 128 plus 64 plus 32, in these place values, right, here's the place values up here, would be 224. And this would be a, there's 8 ones here, another 8 ones right here, and then 3 more ones, so that's 8, 16, 19, so that would be a /19 address space. So go here, so what we're going to leave with is /19 is going to win the day, and /19 will give us 8,192 hosts. Okay, so let's do it. So this would be the magic number here, the last number 1 bit borrowed is in the 3rd place, which means 32. So the magic number in this case right here is 32 in the 3rd place value from left to right. So 1, 2, 3, 32. So the networks will go up by 32. So the first network is going to be .0, .0. The next network will be .32.0. The next network will be 64.0. And the last network will be .96.0. All right, and they will all be /19 /19. And if I wanted to write it out, the subnet mask in decimal, it's right here. I've got the in decimal format, it would be 255.255.224.0. That would be the subnet mask, or /19. So those are our networks, our 4 networks for here. Now, to make this whole thing work, we also have to subnet 2 more networks here for 30 hosts each from the 4 address space. And to do that, 2 networks of 30 hosts each, 192.168.4.0/24. What we could do is, and that would be pretty easy, 192.168.4.0 would be the first one, and we need 30 hosts each, right? 30 hosts. So we would also use a magic number 32 or a /27, right? Which in this case would be a 255.255.255.224, right? And let me get the slash in there. And then the 2 networks would be copy, paste. The next network would be 32. And that would be 2 networks of 32 hosts each. Well, why is that? Well, let's take a look at the subnet mask for that. The subnet mask for that would be in binary. If we were to do a /27, I'll do it right here, it would be, I'll just copy this, copy, paste. All right, we're going to do /27. So that's 8 ones, 16 ones, 24 ones, 25, 26, 27 ones, right? And you can see now that this one is in the place value 32, magic number of 32. So 128 plus 64 plus 32 is 224. And this changes to 255, right? And 27 ones means this changes to 27. And how many hosts would that equal? Well, we've got 1, 2, 3, 4, 5 zeros, or 2 to the 5th power in hosts. The zeros represent our hosts. 2 to the 5th power in hosts would be 32 hosts. Or you could look at it this way. The magic number in this case, since we're in the last octet, the magic number will tell us how many hosts we have in our network. The last one is in the 32's place, so that means there's also 32 hosts. You can do that when it's in the 4th octet, and 32 hosts. So those are the 1, 2, 3, 4 network addresses, and then 2 more network addresses here to map to these 4 networks here and these 2 networks here.